These students are building on their experience of drawing and interpreting graphs to consider real-life situations. The teacher begins with a video of a person on a slide. The students have to think about his journey on the slide and how to describe it.
Nice one. Someone tell me what's happened.
His height increases as he climbs the steps.
Okay, all right. So he's climbed the steps, and what's next?
He sits down at the top of the slide and then he slides down the slide.
Just describe how that happened, if you can remember.
Well, he sat down for a moment.
Yeah.
As he was like pushing himself forward.
At the start of the lesson, I gave the pupils the real life scenario to sort of give them something to aim for in terms of this is what we want. We want to represent this situation on a graph. But I recognised that was too complicated maybe to go into straight away. So we looked at the simplified animation with the car. I want you guys to draw a graph of its journey. Right, it's going along. Ooh. Okay, I'm going to show you that again, just so that you can have a little think.
I think it's going to look like that.
No, wouldn't it go back up there? Because if we're going along...
No, but it stopped at the end, so it might go back up.
But it says distance along the road in metres.
It might look like that. Stops at 4 to 6.
4 to 6 seconds, and then at 7 it starts to go back up.
Yeah, you join it up.
So like that?
You said squiggly. It is squiggly, but what is that representing?
Like the ratio from time to distance or something.
The car will go again.
Using the software, the teacher now plots the journey of the car so that the students can compare this with their initial drawings. Whilst most of the class had drawn what was represented on the board, some students had slightly different graphs that they considered would be a truer representation of the car's journey.
If it was in real life, the car would slow down before it stops, and then when it starts up again, it'd be slower first, then speed up.
Yeah.
So we did it as a curve.
Let's go back to the man on the slide. Go on, Poppy.
We don't know what the height is up, so how do we work out that with his waist?
Okay, so I'm going to show it at half speed now. What I noticed was they made notes of the times when he was at the top, how long it took him to go from standing up to sitting down, how long he paused for, what happened at the end of it. They made those notes themselves. They were maybe prompted to do that from having seen the animation earlier.
Using an estimate that the person in the video is 6 foot tall, the students now draw a graph to represent the height of his waist above the ground against time.
Well, I'm just guessing that it's 9 foot or 10 foot. He sat down at the top and then he stayed there until 11. But then I feel like at the end, when it's like 3, it would start lower because he stands up.
And I like the idea that we get to think for ourselves first and come up with our own ideas.
I like the way it was real life situations, because when you've got a graph and you're just writing stuff down, you don't think you're ever going to use it, but it helps you think about it in your actual life.
That was when he sat down that was when he's walking across. That's when he sat down. So wouldn't it be lower when he sits down? Oh yeah.
You don't realise that you're going on to different waist levels, and then when it's drawn out in a graph, you then suddenly realise how many other factors and how many levels you have to take into consideration before you actually draw your final graph.
It could be more curved because it does gradually, you don't just start going down the slide really, really quickly, you gradually get faster as you go down.
But he stands up at the end.
I don't think I was anticipating them to notice quite as much as what they did, but that was credit to them really, and how well they were noticing things. So he's walking up the ladder, so then it gets to the top. What I think the pupils got from using the real life example rather than using the animation is that they were having to make their own estimates, for example, and there was extra information that they were having to judge whether or not it was appropriate to include.
He sits down, so his waist height drops and gets lower, but
it doesn't happen like straight away or like over a second. It's like, it's not instant, but it's pretty much dead quick.
I think the next thing I'd look at is trying to develop from that quantifiable facts, such as let's work out the speed, let's see when the man's going fast, even perhaps drawing a tangent to a curve to try and see when it's steepest, or trying to find the gradient in that context and actually working out problems from that.